I'm going to show you how to do the shim mod on the LnL AP to tighten your fitment between your shell plate and your subplate. What you're looking at now is just a video in reverse of me putting it together at the end. Trying to just show you how to take it apart right now. And then we'll start looking at the components of it and what you need to measure and what you're eventually going to have to do. This next part already has the mod done, so just ignore it a little bit. Just focus on the pieces that I'm pulling out. This piece is the drive hub. It goes through the subplate up from the bottom. How far it sticks up through the top of that subplate determines how closely your shell plate will ride against the subplate. So we're trying to lower that and bring our shell plate closer to the subplate. You want to use your calipers to measure from the very bottom of this to the top shoulder. Do not measure the protruding key notch. Then you want to measure that flange at the bottom, that skirt, and you want to subtract that measurement from your first measurement. Then you want to take your subplate and you want to measure from the bottom, when you're looking at it from this view, the very bottom, to the very top. The measurement you got on your drive hub measurement should be taller than your subplate measurement, and the difference between the two indicates how much higher the drive hub will protrude from the top of the subplate. I was getting approximately a 12 thousandths difference between my measurements, and that is approximately how far the drive hub protrudes from the top of that subplate. You can kind of see it here as I am pushing it up and down. You see the shoulder of the drive hub come out. Now I've put on the shell plate, which rides directly on the top of the drive hub. And here you can see me, when I lift the drive hub, you see that shell plate lift off of the subplate, and it's coming up a pretty good amount right now. Again, that's about 12 thousandths. Here it is again from a different view. You're able to see as I lift up on the subplate, the drive hub is staying down against the bench, and the subplate has a lot of slop between that drive hub skirt and the shell plate. To solve that slop, we're going to take shims and place them on the skirt of that drive hub, and these are going to act like stoppers to prevent the top of the drive hub from protruding as far as it did before above the top of the subplate. You want them to be within a couple thousandths of your previous measurement. So before, mine was 12 thousandths protruding, so my shims add up to about 10 or 11 thousandths. Which should mean that the drive hub now only protrudes 1 to 2 thousandths above the top of the subplate. You can buy these shims. They're called arbor shims. You want to make sure they have a 1-inch inner diameter and I think a 1.2 to 1.25 OD. I made these from some stuff I had. They're kind of jank, but I think it's going to work. So now you'll be able to see that there's hardly any protrusion at all on this subplate. When you tighten a shell plate down to it, it should be protruding, like I said, between 1 and 2 thousandths, something like that. Just enough clearance for the shell plate to function, but not have hardly any slop in it. To make sure your shell plate still functions, I took mine and I hammered the ball bearings with a 3/16 punch so that they would not protrude at all from the bottom of the shell plate. So you kind of just take those out of the equation and make sure your shell plate can still glide across. Right now, those ball bearings are in place in that, and that's why you're seeing kind of a jerky motion, because those ball bearings are getting stuck. But to test it out, just lift them up a little bit so they're not even in play, and see if your shell plate glides or if it binds up. And here I'm trying to do the test from earlier to see if you can see any slop in there, but there's really none to be found. And here we go, putting it back together. So we put that drive hub in. We put the subplate on top of the drive hub. Make sure that drive hub hits its notch too, by the way. So make sure you tighten these locating screws back. This was what I showed in reverse earlier. So we're gonna just put that center screw in there, and we're gonna lift up on the drive hub to see how far it protrudes, if at all. And again, it should by 1 or 2 thousandths, because if it didn't protrude at all, or if it was recessed, the plate would bind up and not function correctly. So here we got our plate. It's all greased up, so is the subplate. Don't put as much grease on as I did. I learned that because the brass was actually getting kind of caked in it. We got a lock washer, tip from 76 Highboy. Keeps that screw, that bolt in place. And here I'm just showing that it does function. I'm not putting a ton of effort into moving this handle, and it is still rolling across. Sometimes I can feel some slight binding, but I don't think it's too much of a concern. I'll edit the video if I think it is in the future. You can see me here just moving it with my fingers. The biggest force to overcome is the ball bearings in their detents. So this is just a general how-to video. I'm not extolling the virtues of this mod. This is not a review of the mod. I'm not getting into the nitty-gritty or best practices or anything like that. I haven't loaded a single round of ammo on this press. It was just something I wanted to do, and if you've done your research and decided that you wanted to do it, this was just to help you visualize it, see what to measure, see what to look at, stuff like that. Okay, so here's that update I promised from before. Basically what happened was I tuned this pretty much perfectly with, unfortunately, what turned out to be my loosest tolerance shell plate. So it worked great on this. Everything else I had seized up on that. So I didn't want to take all or most of the shimming out that I put in there just to make it work on these while being ultra loose on this one, because it would probably need several thousandths taken out to work on those ones. But since it's working fine with this, that means I would be adding, 5-6 thousandths worth of slop to this, which I didn't really want. So I was trying to find a middle ground. So I wanted to take some out of there, and then on this end, I just wanted to get these working by sanding these down a little bit and just freeing up some of the binding, or all of the binding. I mean, you don't want any of it really. You can see that, the lines through the Sharpie that I drew. And then I drew the lines on the shell plate itself, so you can see where that's rubbing too. So what I'm doing now is I'm just sanding that down, just very, very incrementally, not trying to take too much material off. I think the ones right now that aren't working are just like, they're 45, so it's not like so it's 45 ACP and 357, not precision rounds. I'm not worried about, even if I do end up taking off too much of a plate, it's not gonna make a huge difference. But so that's one thing to just be aware of, that not all your plates are the same. These, after measuring them with some of my stuff over there, there's definitely plenty of variance between one plate to another. One of the things I was able to measure on these plates was that this one, which is the one that I tuned it to originally, which it worked best from, if you're like this on the subplate, the closest point to the subplate on this plate is going to be right in the center. As you get out to the perimeter, it has a constant increase in elevation there, so it's getting farther away from the subplate as you move to the side, and that's why it was working so well. A lot of these are flat pretty much, or almost flat. Some of them actually have the opposite effect, where the closest point to the subplate is on the very edge, and that's where it's going to rub, and the center is actually slightly elevated. So you're really driving down, when you tighten it, you're really driving down this perimeter into the subplate, and that's just, it's binding the whole thing up, it's seizing everything. It's kind of hard to measure because, you'd think it would be easy enough to measure, to just lay it flat, take some measurements here, see what's raised, what's sunken. But I learned that the top isn't machined perfectly either. Or maybe it was machined perfectly, but there's has been some warping potentially. I wasn't able to really measure that, but by holding the flat edge of the calipers up to it, I could see that a lot of them, if you're holding it if you're holding the flat edge here, a lot of them will be bowed out like this, or the opposite, where the center is the highest, and then it bows downward like that. And when you're trying to lay it on a flat surface and then get the measurements on the bottom of the plate, that makes it hard to get, because you think you're flat, but you're actually not. So yeah, just be aware of all that if you're going to try to do this. Figure out maybe what your tightest one is going to be, and then shim it up until that one works perfectly. And then your other ones will be, if they're similar to the one that you based it off of, then they'll all work pretty well. But if you have, like me, one that's really loose, you might still have a plate that's going to be really loose when you have it working with your tightest one. So in that case, you can just deal with your loose one being loose, and hopefully it's not a precision round, like this one's 9mm. If that one's got to be a little loose, I can deal with it. But yeah, you can find a middle ground. You can take out some shims. If these are binding way too much, then take out some shims, but maybe don't take them out to the point where these work perfectly and just glide, and then you'll have this one being pretty loose. Just take out, half the shims, sand these down a little bit, and then they'll all kind of meet in the middle with how well they work. All right, I think that's all for this. Maybe I'll do another update when I get it all working perfectly, if I get it all working perfectly.